Hello everyone and welcome back. In this video we're going to look at identifying where functions are increasing, decreasing, and where they are constant. We will also take a look at relative maxima and relative minima in this video. So we'll look at a few informal definitions here. The first one is a function is increasing when it is rising as we move on the graph from left to right. So if that graph is rising or going up as we're moving from left to right along the x-axis, then that function is considered to be increasing on that particular interval. A function is decreasing when it is falling or dropping down as we move from left to right. So if that function is going down as we're moving from left to right along the x-axis, then in that interval the function is considered to be decreasing. Now a function is constant when it is neither increasing nor decreasing as we move from left to right. The relative minima occurs where at the points where the graph changes from the graph changes from decreasing to increasing. So relative minima will occur where the graph changes from decreasing to increasing. And the relative maxima are located where the points change from increasing to decreasing. So now we're going to take a look at a couple of graphs and state where the intervals where the functions are increasing, decreasing, constant. We'll also look at relative max and relative min. Okay, so taking this graph into consideration, if we look at this graph as it continues to go up and continues to go down here, if we're going from left to right on this graph, then this graph is actually going down as we go from left to right along the x-axis until we get to -3 on the x-axis, and then it makes a change. So this is considered to be decreasing from -infinity to -3. And then at -3 it makes a change. It starts going up. So from the other side of -3 up to until we get to about -2 on the x-axis, it increases. So it continues to go up from -3 to -2 on the x-axis. It increases. And then from there it begins to decrease again. So you see it's never constant. So this function you can see is increasing from -infinity to -3, and again we're looking at the x-axis in relationship to the x-axis. And then from there it begins to increase, but then again it decreases again if we're looking at the x-axis from -2 on out to positive infinity. And again, that's running along the x-axis is what we are referring to with our intervals. Okay, so at -3 along the x-axis, that's where it makes a change and starts going up. So that's when it begins to increase, and it increases until we get to -2 on the x-axis. The function is never constant. Now we have a relative minimum where x is equal to -3. So right here we have a relative minimum. That's where it changes from decreasing to increasing. And we have a relative maximum where it changes from increasing to decreasing at where x is -2, or at f of -2. Okay, let's look at another graph. Okay, so we have this graph here running along this line of y equals 3, and then we drop down and then we pick back up. So we have a constant area there. Then we have a decrease, and then we have an increase. So where from negative infinity, if we're looking again in relationship to the x-axis, from negative infinity until we get to about -1 on the x-axis, this graph is constant. And then we begin to decrease from -1, and we'll say this is about 0.8 to about 0.8 on that x-axis. We begin to decrease, and then we begin to increase again from that point on to infinity. So we have a decrease from -1 to 0.8 running along the x-axis in relationship to the x-axis, and then we have an increase from 0.8 to infinity. However, we also have a constant area here from negative infinity until we get to where x equals -1. So again, we do have a relative minimum where it changes from decreasing to increasing, and that relative minimum is right about there at f of 0.8. And that's all for increasing, decreasing constant, and relative minimum and relative maximum. I hope you enjoyed this video. Hope it was helpful. Look forward to seeing you on the next one. Thank you.